In this video, we're going to discuss linear equations, the graphing of linear equations. We're going to actually graph in slope-intercept form, but before we begin that, we need to have an idea of what the Cartesian coordinate system looks like. The system is actually divided into four quadrants by the axes, this being the x-axis and the vertical one being the y-axis. And these four quadrants are actually labeled quadrant 1 with the Roman numeral, quadrant 2 moving in a counterclockwise motion, quadrant 3, and quadrant 4. And when we plot points, we always begin at the origin of 0, 0. If we move to the right on the x-axis, that's a positive x value. If we move to the left, it is a negative x value. If we move up, we are going to have a positive y value, and if we move down, likewise we have a negative y value. So in the first quadrant, our x would be positive because we would move to the right, and our y would be positive because we would actually move up. Ordered pairs are actually named in parentheses, so we would have a positive x and a positive y, those being numbers depending on how many increments you move. If we move left, that means we're going to have a negative x, and we move up, that is going to be a positive y, and that would place us in quadrant 2. From the origin, if we move left, again that would be negative x, and if we move down, it would be negative y, placing us in quadrant 3. Back to the origin, if we move right, it would be a positive x value, and if we move down, that would be a negative y value, which represents all the points that can be placed on the rectangular coordinate system. If we wanted to determine if an ordered pair is a solution to a given equation, we don't necessarily have to graph it because some numbers are difficult to see, especially fractions, as far as graphing those are concerned. So when we want to check if it's a solution or not, we can use our substitution method to find out if it is a true statement or not. So for instance, if I wanted to test 0, 3, I would just plug in 0 for my x value, so where my x is, I would put a set of parentheses, and then for y, I would substitute in a 3, and then I finish writing the equation. So all I've done is substituted for the x and the y. 5 times 0 is going to be 0, negative 3 times 3 is negative 9, and finishing the equation, we're left with negative 9 equals 9, positive 9, and we know that's not a true statement. So therefore, 0, 3 is not a solution to that particular equation. Now, because 0, 3 is not a solution, does not have any bearing on the next point that we're going to test, 12/5 and negative 1. Using the same equation, the 5 times x minus 3 times y equals 9. Plugging in for x, which would be 12/5, substituting in for y, which would be negative 1. So in this case right here, our 5's cancel, and we're left with positive 12. Negative 3 times negative 1 is positive 3 equals 9. 12 plus 3 giving us 15 equals 9. Well, 15 does not equal to 9, so that is also a false statement. So in this case right here, 12/5 and negative 1 is not a solution. So you have to test these individually. And if it would have been a true statement, say 15 equals 15, then that would be a solution, a point that fell on that line. When we look at graphing, we're going to look at it from the aspect of slope-intercept form. Slope-intercept form is y equals to mx plus b. M representing the slope, which would be a number, and if we wrote it as an ordered pair, 0b, that would be the y-intercept. So it's easy to select your slope and your y-intercept if it's in the form of y equals mx plus b. So the first thing I'm going to do is solve this equation for y, and to be able to solve this for a positive y, the first thing I'm going to do is move the 3x to the other side, bring down the 2y because the 3x is canceled right here. It's better to write your x's first, just to be in the same form of the mx plus b. At this point, we divide everything individually by 2. Some things divide differently than others, so we're left with a positive y equals to negative 3/2 x plus 6 divided by 2, which is positive 3. Well, in this case, our slope is the coefficient of x, which is negative 3/2. Once it's solved for y, your slope is always x's coefficient. Your y-intercept, which means where it crosses the y-axis, is an ordered pair. It is a point. Your x value is always 0 to be able to fall on the y-axis. And then your y-intercept, or your y value for the y-intercept, is positive 3. It's always going to be that number. So when we graph this, we can plot 0, 3. 0 says do not go left or right any along your x-axis. And then the y is positive 3, so we go up 1, 2, 3. That being your y-intercept. Your slope being negative 3/2, slope has another definition of rise over run, or the change in y over the change in x. Since it's a negative 3, we're going to go down 3, 1, 2, 3, and because my run is positive, run means left or right, it's positive, so we're going to go right 2. So what just happened was from the y-intercept, we move 3 down and then 2 to the right due to the sign. Now the negative sign can be with the top or the bottom, but it cannot be for both because a negative over a negative would be a positive. But once we have those 2 points, then we can line those up and draw a straight line. And that would be the graph of our line.